Good afternoon, everyone. So we are going to start this session in a minute. In the meanwhile, please help welcome Yannis and Volker. They are solutions architect in field engineering team at Databricks. So please join me in warm welcoming them. Give it a round of applause.
Shall we start? Okay. Hello, everyone. How has been your day today? Enjoying it? Excellent. And we're just in the first day, right? My name is Yannis, and I'm a cloud technologist at Databricks, which means I'm working with AWS, Microsoft, Google, and define actually joint architectures and deployment scenarios of Databricks for our customers. And as you can tell, actually, from my name and my funny accent, I'm from a country in Europe. And together with me, I'm having Volker.
Hi, everyone. First of all, welcome to Data AI Summit. It's so great to see so many of you here and to have you in this session. I'm Volker. I'm also European, as maybe you can hear from my accent. I'm also working for Databricks. I have been so for 3 years. I work with a team of solution architects who work with many large German customers, actually, many of the multinationals, who are actively looking into multi-cloud or have already done multi-cloud. So what I'm presenting here today with Johannes is a little bit of sort of lessons learned, how you build this. On a personal note, so before I came here, I actually was a data scientist. And it's a little bit of what I'm doing today is a sign of what 3 years at this company do to you, because I'm talking about data governance, and as a data scientist, typically that's what's standing between you and that honey pot of data. It's not something you typically touch or are excited about. But here I am, excited to talk to you with Johannes about multi-cloud data governance.
Yeah, so let's start first of all by defining data governance, right? So, the theme of this conference is Generation AI, right? So, I asked actually ChatGPT to tell us what data governance is, and we received this answer. Now, obviously, I'm not going to read all of that, because it's really long, but it's only telling us that there are plenty of concepts and activities that fall under the umbrella of data governance. So I asked ChatGPT to summarize that, right? So use a much simpler language, right, and summarize that in a single paragraph, and again, it did summarize the paragraph, but there are really plenty of concepts still mentioned there, right? Including privacy, security, compliance, data quality assurance, right, etc. And then we can ask, how are all these related logically, right? So let's take one step back and try to examine actually which are the questions that data governance is trying to address, right? Now, first of all, we need to ensure that the right people have right access to the right data. So the first question is, who has access to what data? And that is really the security and privacy dimension of data governance, right? Then we need to ensure that people in the organization, they can rely on the data so they can make informed decisions, right? And the question asked here is, how do we ensure that we can trust the data, right? And here it is about the process around data collection, data storage, right, quality assurance, right, and these are the relevant dimensions of data governance. But ultimately, the goal of a data-driven organization is really to be able to generate insights from data, right? And we need to be able to prove that these insights are generated in a reproducible and predictable way, right? So and this is where concepts such as data lineage, right, auditing, monitoring, right, these are the relevant dimensions of data governance. Now, obviously, we're not going to cover all these things today. This is really a very excellent topic, right? But we're going to concentrate on the privacy and security dimension that is coping with the who has access to what data, right, question, and under what circumstances. Now, by whom, we're referring really to users, groups, or even services, right, processes that need to access the data. And this is what we call typically principals. Now, by what, we are referring to all types of data assets, right, that we're working with, such as tables, files, notebooks, machine learning models, right, etc. And this is what we call the securables. And finally, privileges are all the specific actions that the principals are allowed to do with securables or not, right? And collectively, we are referring to all these as entitlements. Now, why this is important? Because it is really the management of these entitlements that data governance is all about. Right? Now, of course, when in the real world, we need to manage actually these entitlements in a quite complex context, right? So as we just mentioned, we have to deal with multiple data types that are governed using different approaches or different constructs, multiple technology stacks that we need to stitch together, multiple geographical locations where our data are collected, stored, analyzed with different legislations, different compliance requirements, right? And increasingly, as Volker just mentioned, right, so we have to deal actually with multiple cloud vendors that support our data platform. And as we said actually in the session, we're going to focus mainly on the latter, right? So on the fact that we have to deploy our platform actually in different cloud regions and in different clouds in different actually regions, right? Now, I guess you know that in the Databricks Lakehouse, the solution to all the data governance aspects is Unity Catalog, right? And for those who are interested, there are deep dive sessions on that, right, later this week. Now, Unity Catalog is the Databricks service that underpins all access to data, right? So when the principal is trying to access the data in the Lakehouse, so Unity Catalog is performing, access controls, resolves the logical locations to actual paths in the cloud storage, provides access to data using pre-signed URLs, right? Registers the operation in audit logs, right? Stores lineage information every time new data are written or updated. And then Unity Catalog is not a service actually running on Databricks workspace. Now, actually, serves all workspaces in your organization. Until recently, for those who are familiar with Databricks in several years, right? So the user provisioning, the data metastore, or access control that were scoped at the workspace level. Right? Now, with Unity Catalog, all of these things have become responsibility of Unity Catalog, and then the workspace is now made what its name implies, a workspace. That is a place for people, for a group of people, to do collectively work, right, on the data. And what is really managed at this level now is just the computing resources, that is the clusters, right, and your SQL warehouses. Now, if Unity Catalog does not live in the workspace, where does it live? It lives at the Databricks account level. Now, how many of you have ever launched a Databricks workspace? Right? Not all of you, right? So, for those of you who did it on AWS, very likely you have done it actually using the account console, right? And this is actually where you can see all your workspaces, right, in your Databricks account. And you know that each workspace can be associated with a different AWS cloud account. And of course, you can have all your workspaces using the same AWS account, but this is not necessarily speaking required, right? Now, on Azure, on the other hand, if you have ever created a workspace on Azure, you're doing it from the Azure console directly, right? And if you have admin rights at the AAD tenant level, right, it's only then where you can have access to Databricks account console, right, which provides you really a read-only view of all the workspace you have created. Now, in this case, the Databricks account is mapped one-to-one to your Azure account, right? So it is one Databricks account, one Azure account at the tenant level. In the case of GCP, you have something in between. Actually, you start with the Databricks account console, right? But you can still create several workspaces under different projects, but you're still actually using a single GCP account. Now, for those of you who have not seen it, never seen an account console before, this is how it looks like on Azure. This is how it looks like on GCP. This is how it looks like on AWS, right? So really very similar, right? And as we mentioned earlier, Unity Catalog now living at the at the account level, right? And with user and identity management now being part of the responsibility of Unity Catalog, one of the common menus that you will see in all account consoles, for all clouds, is user management, right? And if we click through that, so you arrive at the page where you can list and manage all the users, but not only that, this is actually where you can define other principles, as we discussed earlier, right, such as groups or services. And of course, you can manage actually users and groups, right, using the UI. However, in a real-life scenario, most likely you have a single identity provider, like Okta, right, or Active Directory. And then what you will be doing is you will be using the Scheme API to provision the user in each of the accounts, of the Databricks accounts. So if you are in a multi-cloud environment, you will have typically one Databricks account per cloud, and then you will need to, from your identity provider, which you have hopefully one, right? You are going to provision actually the users using a Scheme API to each of these accounts, right? And then what you do is you assign the users from the account level into the different workspaces, right? Using Databricks account API. Now, provisioning, of course, is one thing. Authenticating the users is a different one. And in an enterprise setting, especially in a multi-cloud environment, you would typically use a single sign-on actually for this. So here actually we have an example. What I'm showing you is a typical example where you have a company where they started with Databricks on Azure. They used the Azure Active Directory for user identities and user authentication. And then now when you want to go on AWS, for example, to launch actually workspaces on the AWS cloud, so you, first of all, you're using a Scheme API to provision the users, and then using SAML, and lately, most importantly, OIDC, you set up actually SSO so that a user can log in at the account level, but then you also need to set up SSO at every workspace, right? And so far, actually, we have been doing it using SAML, but since last week, this is quite new, we have simplified the process with the SSO federation that allows admins to configure a single sign-on at the account level and all the workspace at once. Right? So this way, you can manage actually in a very single, using actually your single identity provider, all the users across actually the cloud deployments. Now let's get back a bit to the account console. And as we mentioned earlier, right, the data management now is handled by Unity Catalog that resides actually the account level, and therefore here you will find also another common menu, right, which is the data. Now, what do we have at this level? So we can manage the Unity Catalog metastores, right? Now, if we click actually through through this menu, so we see actually a list of the metastores in our account. And one thing to notice here is that there is a metastore per cloud region, right? So, and this means that the metastore has scoped really at the cloud region level, which is exactly the same case when you have a workspace, right? So Databricks workspace, it's actually scoped actually in the corresponding cloud region, whatever cloud it is, right? So from the account console or using the Databricks account API, you can assign a metastore, right, to one or more workspaces in the same region. But reversely, actually, a workspace can be assigned only to one metastore, which is metastore you have actually for this region, right, for this given cloud. Right? Now, and in the metastore, you have all the data assets, tables, views, volumes, which is nothing else actually but folders actually on cloud storage, right? Machine learning models. And they're organized actually in catalogs and schemas. So when we want to access an asset, a data asset in the workspace, in order to fully qualify it, we have to specify not only its name and its schema, but also also the catalog, as we see actually in this example. Right? Now, the metastore is also owning the relevant entitlements and securables, right? So we said data governance is all about managing actually these securables. So this stay with the metastore, right? So, and here, they can be granted, so privilege can be granted either by using standard SQL, right, as people actually have been used to, or even with APIs, right? Using Databricks catalog APIs. So in this particular example, we talked about, you see in the first entitlement, the first line here, the principal is the account users group. The securable is the sales schema, right? And the privilege is actually the use schema to relate actually with the diagram I showed you earlier. Right? Now, with Databricks, of course, we can control access even at the row and column levels of a given table. And the way we're doing it today is using functions that are defined under a schema, right? Now, this is why this is important to remember, because when sharing data across clouds, right, we need also to propagate the access controls, right? So this means that you have to make sure that the similar function is also defined also a destination, right? So when you are sharing data across cloud boundaries. Now, I mentioned data sharing because secure and resource-efficient data sharing is really the cornerstone of any multi-cloud deployment, right, for Databricks. And because of that, this is based on Delta sharing, which is an open and cross-platform protocol that allows you to access Delta Lake files on the cloud storage in a live and quite secure manner without the need of replicating data, right? And the advantage of that, as it is natively integrated actually with Unity Catalog, it allows you to centrally manage and audit all shared data across actually business units or across clouds. So with Delta sharing now on Databricks, how does it work, right? So data are shared between two Unity Catalog metastores, right? Which means in two different clouds, which means in two different Databricks accounts, right? One on one cloud, one on the other. And the way we set it up is the following. So on the source metastore, we define a recipient, which is nothing else but the ID of the metastore on the destination side, right? And this becomes a principal in Unity Catalog, right, on the source side. Then we define a share, that is simply the list of the assets that we would like to share with a recipient, and we grant actually select privileges to the recipient on the share, right? So that is a destination metastore. Right? While on the other side, on the destination metastore, we define the source metastore as a provider, and we create a read-only catalog for the provider and the share, right? And finally, and this is very important, what you need to do is really grant the access to the users in that account actually on the shared assets. And then for this last step, as users and groups are centrally defined and mirrored in the two Databricks accounts using the schema, the schema API as we discussed earlier, this means that you need to also mirror the corresponding entitlements, right? So, because Delta sharing only shares the data and not really the entitlements, okay? So, and you really need to do that, and really the best time for granting the privileges at the destination is really at the same time you're doing you're setting up actually the share, okay? Now, of course, you can do this manually, but this is, in the production scale, this is not really doable, right? So you need to automate that. So how can we automate that? Yeah, you can rely on scripts and things like that, but really the best way of doing that is really to go and use a solution like Terraform, right? That is using the Databricks and Unity Catalog APIs under the hood, right? So if you go and visit the Databricks provider of Terraform, so under the security and Unity Catalog sections particular, so you will find example resources for example, creating a user, right? Or assigning a user to a workspace, or granting privileges to users and groups, or even defining a data share, right? Now, and thanks to that now, you can fully automate the scenario that we just described in the previous slide. So this is an overview of the tools that Databricks provides you to facilitate multi-cloud data governance. But now let's hear from Volker how these things are actually used in practice in various organizations.
All right. Thanks, Johannes. Am I on?
Yeah.
Excellent. OK. What I'm going to now do in the second half of this talk is take you through a few common use cases that you're actually having to solve in practice and putting all of this together to make data teams work together. And for what I'll do for that is briefly introduce a very stylized examples that you can think of sort of a number of my customers and their setups taken together as an average and focusing on a few features and a few teams here. It'll be some multinational company that is heavily leveraging ML. So they're doing supply chain forecasting. I'm pretty sure they're busily training LLMs and chatbots. They have chosen to operate, or at least give the flexibility to operate on different clouds for their subsidiaries. And then there also is there's an element of some data of the company being managed centrally, but owned by the local subsidiaries. Organizationally, we look at a few teams and how they're interacting here. We'll have 3 different org pods and 5 different teams in them. First, there's central IT, in which we have one team that is providing tooling and guardrails on the different platforms. We have one team, the ERP team, that centrally manages the ERP data. We have one ML team that does most of the dev work across company and rolls it out across the org. And then we have data teams independently operating in the different business units in the different regions. And they have to implement the data governance, and on the one hand, it's very flexible in how the teams work, but also, of course, respecting both data ownership and also the rules and regulations of the different markets. Architecturally, we'll be focusing here, we're looking at an example where the company is now operating in 2 different clouds. So we've got central IT that's operating on AWS, and say for the sake of argument, it's US East 1. And then there's a European subsidiary that's operating in Azure. The ERP data, as you can see here on the left, is actually only available in one region, in this case, the AWS. And as Johannes explained, the fact that they're on 2 different clouds and regions means that in Databricks, they're actually having to bridge data between different metastores, for which they're leveraging Databricks-to-Databricks sharing based on Delta sharing. They're managing all their assets in Unity Catalog, so not just tables, but also models and features are already managed in Unity Catalog. And what you can see here is that on top of that, there's a centralized IDP as maybe Okta, Active Directory, where all the identities of the entire company are stored and synced across the regions. Let's look at first what the cloud team is doing here. They're actually a pretty important key and cornerstone to make this whole setup work. Not only, of course, are they the ones who are kind of setting and configuring the different cloud environments and setting guardrails, giving permissions, making sure that costs are allocated. They're also the ones who are heavily leveraging Terraform, for one, because they have to be productive and very reactive in how they provide workspaces to the different teams to make sure that users are synced there, but most crucially also to make sure that the entitlements that these users are having, so the group memberships and the permissions that these groups have, that there too are synchronized across the different environments. And for those, they would be typically relying on Terraform templates, as Johannes just pointed out to you. Now, having covered those, we'll look at as a starting point, we look at data sharing between the teams, but still in the same cloud. And we'll do that to introduce the use case of this a little bit in more detail. So as I mentioned before, the company is operating on a central ERP system. To those of you for whom that doesn't mean something, so think of an SAP, of an Oracle system, where all the bills, the customer relationships, the orders are stored and processed. And to make these data available for analysis, there is a data team that is ingesting those data into Unity Catalog. They're doing quality control. They're doing brown, silver, gold. But crucially, they're managing these teams actually only for the local subsidiaries, because the governance model is that the European customers are only, they belong to the European organization, and the European organization then has ownership of these data, and they're the only ones who are allowed to see that. So in order for that to accomplish that, after having ingested the data, the ERP data team is then having to define row-based access controls on those data, which they can do in Unity Catalog, which means that now the BU team has access to their data. There needs to be no copying, but instead they can access the data in the ERP data catalog, and they'll only always be able to see their data. In the context of the second team now, who's residing on the diff in Azure and in a different metastore, what the teams are doing is the same, but of course now we're actually having to bridge the different metastores. And for that, as I mentioned, we'll be leveraging Databricks-to-Databricks sharing. So the setup becomes a little bit more complex in that now, after having ingested the data into the ERP catalog, the data team there defines a share in their Unity Catalog metastore. They create a recipient for the other metastore, and then they add all the ERP data to it, which makes it available in a read-only catalog in the European metastore on Azure. Now all what's left for them to do is to synchronize entitlements through these Terraform templates to make sure that there too the same permissions apply and that these same row-based access control become synced to the second metastore, such that that data team can then only access again their data, and from there on they can enrich those data, build reports on them, and crucially also, of course, feed and construct data pipelines that will be focusing their ML operations. Now this is so far all, data could be mostly thinking about BI use cases. What now comes in addition to is some of the complexities that are introduced when we're doing ML, which of course now means we're having to model, in principle, models. We're having to manage models as well. And for that, let's look at how they do that. I mentioned before that the company has decided to centralize all the resources in a single team, mostly probably because it's, as we know, that still takes considerable skill and expertise to have a strong ML team. And also the company is actually still having operations and procedures which are sufficiently similar across the regions such that it makes sense to centralize these efforts. This ML team is following MLOps best practices as portrayed in the Databricks MLOps white paper, which means they are working with models as code. They're versioning models in a repository. They have a branching strategy. They have different environments that they work on. And then what they're doing after having done development work, they're rolling these models out into production in the different cloud regions. And what we now want to do in this remainder of this example is to look a little bit how you're applying data governance to make this work. For that, I've taken an architecture, again, that you can see in more detail on the MLOps white paper of the different environments and stages involved, and extended that to a multi-cloud context. And what you're seeing here roughly from left to right is this team is part of Central IT, so they're operating in the US on AWS. They're working in dev environment, they're doing experimentation, discovery, and then some early experimentation around model development. They define featurizations, and at some point they come up with a new iteration of an ML model. At this stage, they've got that ready. They'll trigger a CI pipeline, move to a staging environment. All of this is so far probably happening either on synthetic data, explicitly created for model development, or we see that also with customers, it may be on a read-only copy of production data. It's taking place in a separate catalog, or maybe with a very reduced scope. So far, there is also no need to cross clouds. When that is happening is after some of the CI testing in the staging environment has concluded. At this point, this is where they now have to deploy these models across the different, moving them productions across the different regions. So the way this works is that now, at that point, a process is triggered in the production environments in both cloud regions. Of course, it makes sense to test the model also on the production data in our regions to make sure that the models are actually performing in the different regions and having sufficient satisfactory results. Here, the way to make this work with the data ownership of the local teams is that these jobs are then typically running in a very automated way with service principal users. Only those users will then need to have access to those underlying data. The model will be trained, QA tested, all of that in an automated way, and then either be deployed for serving or, of course, for batch scoring. And then the output data of that, too, will once again live in the local catalogs of the business units who then have to operationalize these. And the way to then make that work in the centralized model development is that through the observability features and the end-to-end monitoring of Databricks, these are then creating observability tables or dashboards which can either be accessed by the model team or shared once again back through Databricks-to-Databricks sharing. To give you some time for questions, I know this was a quick ride. We wanted to summarize a few things for you to take away, if nothing else, from today. So in summary, for multi-cloud data governance with ML, identities need to be synced with SIM and OIDC. For that, entitlements need to be synced along with them with the shared data. Data can be shared, and Databricks-to-Databricks sharing, leveraging Delta sharing is key to that. And with ML, you want to follow MLOps best practices, treat models as code, and sync your input data across environments. And with that, we'd like to thank you.
And we'll have a few